To do solution concentration problems, the key is to manipulate your units. Units and dimensional analysis, also known as the unit factor method, through which we cancel unwanted units, are going to be key to solving all of these problems. And in many senses, they're just complicated unit conversions. Let's take an example. How many moles of sodium hydroxide are in 30 milliliters of 0.10 molar sodium hydroxide? So this big M, we pronounce molar, and it stands for moles per liter. Okay, that's just a little review of what molarity is. This is our main unit of concentration in general chemistry. So we can sort of translate the words into math. 30 milliliters of 0.10 molar, that of becomes a multiplication sign. So we have 30 milliliters of 0.10 moles per liter. And the moles per liter are the moles of sodium hydroxide per liter of solution. So in doing this, we see that we have units on the top over here and we have units on the bottom over here, but the units don't match. So we need to do a conversion to convert those milliliters to liters. We know that there are 1,000 milliliters in a liter. So you see here I've used a dimensional analysis technique to enable me to cancel out my milliliters, cancel out my liters, and now I'm left with my desired units, which are moles. So doing this gives me 0.0030 moles of NaOH. So we can always transform a volume of a given concentration of any compound to the number of moles if we know its molarity, if we know its concentration. Let's do a similar example, just making it a little bit more complicated. How many moles of hydroxide, OH minus, the anion, are in 50 milliliters of 0.20 molar barium hydroxide? So here we're being asked for just that anion, not for the moles of barium hydroxide, but for the moles of hydroxide. And if you look carefully at the formula, you can see that we're going to have, for every 1 mole of barium hydroxide that dissolves, we're going to have 2 moles of OH minus. Okay, so we're going to have 2 moles of OH minus coming out per mole of barium hydroxide that dissolves. So this is going to affect our calculation here. We can use the same strategy as in the previous problem. We have 50 milliliters of, the of is like a multiplication sign, 0.20 moles of barium hydroxide per liter of solution. Okay, that molar is moles per liter. We need, once again, to get rid of the milliliters, to convert milliliters to liters. So there's my conversion factor. But here we need one more thing. Because we're being asked for moles of hydroxide, we need to take into account the fact that we're going to have 2 moles of hydroxide produced for every 1 mole of barium hydroxide that dissolves. So if you look carefully, again, we've used the unit factor method. I'm getting rid of my milliliters, I'm getting rid of my liters, and I'm getting rid of my moles of barium hydroxide to be left with moles of just hydroxide by itself. So this will give me 0.020 moles of hydroxide in that solution, in 50 milliliters of it. All right, let's do another example now. How many grams of sodium chloride are required to prepare 0.100 liters of 0.050 molar sodium chloride? So we're making a saline solution here. And here it's similar to the previous problems, except I'm going to want to first, I'm going to want to figure out how many moles of sodium chloride I'm talking about, and then I have to use the molecular weight of sodium chloride to convert to grams. So I have 0.100 liters of 0.050 moles of sodium chloride per liter. Okay, just taking that molarity and multiplying it by the volume. I want the grams, so I need to figure out what the molar mass is of sodium chloride. That is going to be about 58.4 grams per mole. Okay, you can use the periodic table to calculate the molar mass. And now I've set it up so I can cancel out the liters, cancel out the moles, and I'm left with grams of sodium chloride. So you should get an answer that's about 0.29 grams of sodium chloride. All right, so there you're just using the molar mass to convert from moles to grams. One final example, what volume of 0.050 molar sodium chloride contains 0.584 grams of sodium chloride? So here, we kind of want to do the previous problem in reverse. I always start with what I have when I'm doing problems like this. I know that I am trying to figure out the volume that has 0.584 grams in it. So I'm gonna start there and see if I can convert to moles and then maybe use the molarity to convert to volume. So 0.584 grams of sodium chloride can be converted to moles through multiplying by the reciprocal of the molecular weight. So that molecular weight is 58.4 grams per mole. Okay, so in doing that, I'm getting rid of the grams and I'm left with moles. The other thing the problem gives me is the molarity. And I know that the units of molarity are moles per liter. That means if I take the reciprocal of the molarity, if I put the moles on top, the liters on top rather, and the moles on the bottom, okay, that's just the reciprocal of that molarity, then very conveniently, I can cancel out the moles and I'm left with liters. And liters are, of course, a unit of volume, and that's going to be exactly the quantity that I want. So this should give you an answer of around 0.20 liters of that solution.